This lesson is on linear inequalities. And so I would assume that you've probably learned about linear equations before this. If not, you probably should review linear equations. So the difference between a linear inequality and a linear equation is instead of an equal sign, you have an inequality symbol. So less than, greater than, less than or equal to, greater than or equal to. All right? In a lot of ways, we're going to treat this the same way that we treat a linear equation. So I'm going to assume that you already know about linear equations and how to graph them in this lesson. But this first example here says, is the ordered pair a solution of this linear inequality? And so all we're going to do to check this, the answer is either yes or no. We're just going to take this x and y value and plug it in to the inequality. So I'm going to plug in 2 for y, and I'm going to plug in 1 for x. I'm going to go ahead and simplify this, and I get 2 is greater than 1 minus 3 is negative 2. That's a true statement, so the answer is yes. 1, 2 is a solution to this inequality. Now, with linear equations, there was only one solution to that. With a linear inequality, there are multiple solutions because it's not just saying y has to equal this, it's saying that y has to be greater than this. So there are lots of points where y is greater than x minus 3. So it's not just one solution, there's many solutions. All right, so let's check this. I'm going to plug in negative 3 for x and negative 7 for y. So that gives me negative 7 greater than negative 3 minus 3, negative 7 greater than negative 6. I always think of negative numbers as being backwards from positive numbers. So if these were positive, this would be true. But since they're negative, this is not true. So the answer is no, negative 3, negative 7 is not a solution to this inequality. All right, so that's the first type of problem you might see. So let's move on from there. So graphing linear inequalities. We're going to use a lot of the same things that we did with linear equations. So if you think back to linear equations, this is in slope-intercept form. Y, and I'll just put, instead of an equal sign, I'll put the greater than sign, mx plus b. Okay, so we're going to treat this just like a linear equation, except that there's an inequality symbol there. So if we look at this, the slope of this line is 1. And to graph it, I'm going to use 1 over 1 because of rise over run. The b represents the y-intercept. And so again, I should have said the m is 1 because there's a coefficient of 1 in front of the x that's not written. So the coefficient of x is the slope. The y-intercept, since this is minus, the y-intercept is negative 2. All right, so remember to graph these, what you would do is graph the y-intercept, which is negative 2. That's the first point you would graph. And then you would do rise over run. And this is a positive slope, so I know it's leaning to the right. So I go up 1 over 1. All right, so far there's been no difference between graphing this as a linear inequality versus a linear equation. So here's where the differences begin, okay? So if there is not a line underneath the inequality symbol, then we use a dashed line. If there is a line underneath it, meaning or equal to, then we use a solid line. So since this is greater than, not greater than or equal to, just greater than, then we're going to use a dashed line. And I cheated, and I've got a line hidden down here that I already created. And so I'm just going to bring that in here. All right. Now we're not done yet. All right, so there's our first difference. With linear equations, it's always a solid line because the line represents the solutions to the equation. Any point on the line is a solution to the equation. Well, in this case, the points on the line are not solutions to the equation because it's not or equal to. And that's why this is a dashed line. So where are the solutions then? If this line doesn't represent the solutions must be somewhere else. All right? So the solutions are either above this line or they're below this line. So how do we decide whether they're above or below? Well, the first way that we can check is by plugging in a point. So here's an easy point. So I'm going to say plug in 0, 0 and see if it's a solution. So again, our solutions are either above this line or below this line. And so I'm going to plug in a point above the line and see if that's a solution. If it's not, then all our solutions are below the line. And I'll show you how we're going to show that. So I can pick any point I want. 0, 0 is the easiest point to pick, so that's why I picked that. So if you can pick 0, 0, that's always a good point to pick. All right, so let's plug in 0, 0. Little line here, and I'm going to write plug in 0, 0. So when I plug that in, I get 0 is greater than 0 minus 2. So 0 is greater than negative 2. So is that a true statement? Yes. So the way that we show that the solutions are above the line is by shading this area above the line. And that means any point above this line is a solution to this linear inequality. Yes, so shade above. So let me get my highlighter here. We'll use yellow. And so I'm going to shade on this side of the line. And a lot of times students will like to use colored pencils to do that, especially when we get into solving systems of linear inequalities. Colored pencils come in really handy. Shade this. And so that is the graph of that linear inequality. So it's not just a line. It's a line that's either dashed or solid based upon what type of inequality you have. So or equal to is a solid line. If it isn't or equal to, it's a dashed line. And then you have to shade either above the line or below the line. So again, any point in the shaded area is a solution to the system, or not to the system, apologize, to this linear inequality. So again, let's try a point. So let's look at this point right here. This point right here is 0, 8. So if I plug in 0 for x, I'd have 0 minus 2 is negative 2. And I plug in 8 for y, and I'd have 8 is greater than negative 2. That's true. Likewise, let's look at a point down here that's not true. So let's look at 8, negative 2. So x value of 8, a y value of negative 2. So if I plug in 8 for x, I'd have 8 minus 2 is 6. Plug in negative 2 for y. So I'm looking at this point right here. I'd have negative 2 is greater than 6. That's not true. So any point on this side of the line will not be true. Any point on this side of the line will be true. And by the way, since this is a dashed line, if you pick a point that's on this line, it will not work. It will not be true. So look at this point right here that's on the line. So that's 3, 0. So x is 3, y is 0. So if I plug in 0 for y and 3 for x, I'd have 0 is greater than 3 minus 2. So 0 is greater than 1. That's not true. So any point on the line is not true since this is a dashed line. All right. So let's look at some more examples here. All right. So what is the graph of y less than or equal to 1/2 x plus 1. So first of all, since this is equal to, I know it's going to be a solid line. And again, this is in slope-intercept form, mx plus b. So the slope is 1/2, and again, that's rise over run. That's an ugly E. Wow, now it's even worse. And the y-intercept is 1. So you would graph the y-intercept at 1. You do rise 1, run 2. It's a positive slope. It leans to the right. So up 1 over 2. And again, I think I cheated. I already have a line. Steal this just to save time. I'm sure you have better things to do. End of this. So there's my graph, solid line, and then we have to shade either above or below. So again, plug in 0, 0. So let's check 0, 0 and see if it's a solution. So that would give me 0 is less than or equal to 0 plus 1. So 0 is less than or 0 is less than or equal to 1. That is not true. Wait, sorry. What happens when I do this on Sunday afternoon? 0 is less than or equal to 1. So that means, since this point is a solution, that means all my solutions are on this bottom side of the line. All right, so we're going to highlight the bottom side of the line. And just as a reminder, since this is a solid line, that means that points on the line, ooh, got a little crazy there. Points on the line are also solutions to this. So any point over here that's shaded, if you plug that into the inequality, it will be true. Any point above the line will not be true, and any point on the line will be true. So let's check this point right here that's on the line. So this is 0, 1, 0 for x, 1 for y. So if I plug in 0 for x, I have 0 plus 1 is 1. And I plug in 1 for y. 1 is less than or equal to 1. Because of the or equals to, it's true. So any point on this line is true, and any point below the line. And it's a solid line because it's or equal to. All right. All right, what about horizontal and vertical lines? So x is greater than -1. So x and -1, I'm going to put a dot. If I was to go with a horizontal line, it would go through all the x values, but this can only go through an x value of -1. So that means this is a vertical line. That's how I remember horizontal versus vertical. If I went horizontal, it would go through all the x values, and it's only supposed to go through this one. This is a dashed line because it's not or equal to. So let's plug in 0, 0 and check that. Plug in 0, 0. So we're trying to figure out our solutions on the right side of the line or on the left side of the line. Which side are we going to shade? So if I plug in 0, 0, I would have 0 is greater than -1. That's true. So that means I'm going to shade on the right side of the line. Let me get my highlighter. We're shading over here. And it's a dashed line, which means that points on the line are not solutions. The only solutions are any of these points over here. I'm getting tired of shading, so I'm getting messy. Hopefully my students will do better than me. So any point over here to the right of the line is a solution. So y less than or equal to 2, that's a horizontal line going through 2 on the y-axis. Again, I think I cheated. I did. Down here, That's not what I meant to do. What that? No. Yes, that. So it's a horizontal line going through 2 on the y-axis. So we want to check to see if 0, 0 is the solution. Sorry, my phone is dinging. Plug in 0, 0. And you would get 0 is less than or equal to 2. That's true. So that means we're going to shade below the line because 0, 0 is a solution. So any point down here is a solution. And since this is a solid line, keep in mind that any point on the line is also a solution. So any point on the line is a solution, and any point below the line is a solution. I feel like I'm in kindergarten again. Always had trouble staying between the lines. That's probably why I had to repeat kindergarten, but don't tell anybody that. All right, so let's see. Last one here. So the last one here is they give you the graph and they want you to write the inequality. All right, so I said the first step is you should decide which inequality symbol to use. Well, there's something I haven't told you yet. So how have we been deciding which way to shade, whether above or below? We've been plugging in 0, 0 to see if it's a solution. If it is a solution, we shade on that side of the line. If it's not, we shade on the other side. That method always works, but there's a trick. If your inequality is in slope-intercept form, then anything with greater than you shade above the line, and anything with less than you shade below the line. So this was greater than, and I shaded above the line. If I have one with less than, I do. This one was less than, and I shaded below the line. Now that only works if it's in slope-intercept form. But for this last problem, we get to choose what form we're going to write it in, and I would write it in slope-intercept form so that we can use that trick. So since this is shaded below the line, that means, and I forgot one other piece, and it's a solid line, so no, it's or equal to. So since it's below the line, we're going to use less than or equal to. So shaded, the reason I'm choosing this is because it's shaded below the line and it's solid. So it's shaded below the line and it's solid. So that's how I know that it's less than or equal to. All right, if it was greater than or equal to, it'll be a solid line shaded above. All right, so let's find the slope. So we need to pick the points on the line. So here's one good point. Again, I'm looking for points that occur at intersections in the grid line. And here's another good point. You can pick any 2 good points you want. So like there's another point here, there's one there, there's one there. Pick any 2. They all will simplify to the same thing. And so for the slope, I'm looking at a rise of 2 and a run of 1. And it's positive because it's leaning to the right. So the slope is 2 over 1 or 2. The y-intercept is right here. Y-intercept equals 1. So b equals 1. And so again, I'm going to write this in slope-intercept form, which is y equals mx plus b, except when I'm so we have y, we already chose our symbol, less than or equal to because it's a solid line and it's shaded below the line. So the less than tells us it's shaded below the line. The or equal to tells us it's a solid line. The slope is 2 and the y-intercept is 1. All right, so that's it. A lot of information there. I hope that that was helpful to you. If you need to, go back and watch pieces of it again. All right. So feel free to leave me a comment, like and subscribe if it was useful to you. And until next time.